Here we go. So before, guys, if you can see the screen here, we said systems of equations where you have at least two equations with the same variables. Like this one had x, y, this one had x, y. And we were able to check and say, okay, these aren't systems of equations. No, because these two are just one equation and this one is two equations, but they don't share the same variables. And we sorted those out. And then we started saying, okay, if I give you a coordinate point like this one that says 2, 5, can you substitute those values in to these two equations and see if it works, right? So we did that, and if we substituted the values in, the x in and the y in, and you got a true statement on both, was that a solution, yes or no? What do you think? In the chat, just give me a quick agree or disagree. If I plugged in this 2, 5 into the x and the y here, and it gave me a true statement and a true statement, does that mean it's a solution or not a solution? Okay, and it's a solution. Good. Zeta, what do you think? All right. If you're still thinking on it, that's okay. So it would be a solution. Good job, Emmett, there. It would be a solution if you plug in the coordinate point and it makes this true and makes this true, then it is a solution, okay? Good job. So we did a couple of those and we said, you know, this one would be, this one wouldn't be because it didn't work for both. And then we did some practice. So today I'm saying, what if I don't give you a point, okay? What if I say, here's 2 lines, I want you to find the solution. Could we do that? So take a look at the screen here. The solution is going to be the point where both equations meet if we graph them. Okay, so you guys will learn in 9th grade, I believe, you'll learn 3 ways to solve these systems of equations. This is just one way, but that's the only way we're going to look at this year is solving by graphing. Okay, you guys got that? Sweet. So let's go ahead and scroll down. So it's going to involve graphing 2 different lines. So take a look at the screen here, guys. Good, correct. Yeah, if the first, I don't know what's wrong with me. Okay, you are correct. If the first one in the box, like if you're talking about the previous ones we were looking at, if we were just checking a solution, if it doesn't work for either one of them, then it's broken, right? It doesn't work. Good point. It has to work for both. Alrighty, so then let's check this one, finding the solution. So this is kind of the basic premise of what we're going to do. We'll graph 2 different lines and see where they intersect. Okay, you guys have all graphed lines before, but it's been well, we did it just the other week, right? So hopefully we can graph a linear equation. But just in case we can't, we're going to look at it a little bit today as well. So here's the 3 steps. Step 1, you graph your 2 equations, okay? So let me draw it here. You'd graph this guy, y equals negative x plus 4, and you would graph this guy, y equals 3x. Okay, once you graph those 2 equations, you want to find where they intersect. Okay, and then once you find where they intersect, you can always check your answer by plugging that coordinate pair back in, just like we did on Tuesday. Okay, so check out our picture here. So this is already kind of done for us, but I want us to kind of look at it and walk through it in our heads. So if I wanted to graph this first one, guys, y equals negative x plus 4, Don't forget that slope-intercept form is y equals mx plus b. So I want you guys to tell me two answers here. I want you guys to say on y equals mx plus b, our slope-intercept form, what does the m stand for and what does the b stand for? That's our first question. So I guess I'll pause there. What does our m stand for and what does our b stand for? If I want to fill this in, what should I write? Okay, thank you, Emmett. And what do you think, Zayd? Are you able to type in the chat? What do you think those represent? Alrighty. So with our slope-intercept form, again, we looked at that a bit before when we were graphing just linear equations. You are correct, Emmett, there. M represents slope, right? And the B represents our y-intercept. And again, what I said the other day still applies. The nice thing about math is usually the name of things kind of give away what it's talking about. So this is called slope-intercept form because it gives us the slope and the y-intercept. So here's our slope and here's our y-intercept. Now, the second question is, where do I start to graph these? So like if we're looking at this one first, am I going to start where? Where do I start when I want to graph this? If I said graph this, where are you going to start? We have a slope and we have a y-intercept. With those two pieces of information, where should we start? Where can we start? Y-axis, okay. Good, so we can start on the y-intercept, good, which would be on the y-axis. And reason being is because otherwise we don't know where to start, right? We have a slope, so we know it's like, you know, at a certain angle, but we don't know if that line's down here or up here, right? So without starting at the y-axis, we have nothing. We don't know, or the y-intercept. So we're going to start with that y-intercept of 4. And all we do is we count up and we say, okay, on my graph, 1, 2, 3, 4. So 1, 2, 3, 4. And I place a point. So that red dot that I'm drawing, that's where we would start. And then we say, okay, what's my slope now? It's whatever comes in front of the x. So that's going to be a -1 if there's nothing else there, right? So my slope is -1. Or if I want to draw that as a fraction, so to speak, I could say -1 over 1, right? Because I can put anything over 1, it doesn't change it. So my rise is -1, and my run is 1. Rise over run. Rise over run. So I go down 1, right 1, place a point. down one, right one, place a point. Down one, right one, place a point. Like that, down one, right one. And then I just connect all those. That's my first line. That is this one. So I'm going to put a little check by it. And then I would do the second one. Y equals 3x. And does it look like there's anything right here? Does it look like there's a y-intercept? No, right? So what that means is that my y-intercept is going to be at the origin. So I'm going to go over here and I'm going to start at the origin. Place my point here. And then that's where I start. And I look at my slope, which is 3. So I could write that as 3, or I could write it as 3 over 1. Put anything over 1, right? 3 over 1. And that's, again, rise over run. So rise 3, run 1. So I rise positive 3, 1, 2, 3, run positive 1. Up 3 over 1. And I can even go down here. Rise 3 over 1. So that would be right there and right there. So then I connect all those lines, all those dots. And that would be that equation. So then all you do, the easy part then, is you say, okay, well, I graphed 2 lines. I've known how to do that. And now you just look at where they hit. Where does it look like they hit? 1, 3, right? So then I would say, okay, 1, 3 is my solution. Let's see if I can get a cool color here. Okay, so 1, 3 would be my answer. And then I could always check, right? I could plug in my 1 for x, both my x's, and 3 for my y's, and it should give us a true statement. Alrighty. So let's look at another one together. And I want you guys to follow along with this. Good. Sorry, I just saw your comment. 1, 3 is where they meet. Yep, so this would be our solution right here. All right, guys, so on the Google Draw file that I shared with you guys, so yeah, with the Google Draw file, this is the first question on that one, okay? So I'm going to share that in there for you, Eleni, welcome. If you copy and paste this link, oops, try that again. If you copy and paste this link, you can get to a file and then you're going to click File, Make a Copy. And that way you'll have your own copy that you can draw on, okay? Okay, once you guys get that ready, can you give me a thumbs up reaction? Okay, good. There's actually a little button near the bottom that says reactions, and you can use that one too if you don't have your screen on. All right, we'll say about 10 seconds, 15 seconds. Make sure that way I make sure you guys have your copy, because you guys are gonna be working this one with me. All righty, so practice question numero uno. You guys, we're gonna do our 3 steps. Step 1 says graph the equations, right? That's what we're going to do first, is graph the equations. Then we're going to find out, hey, where do they intersect? And then we're going to check our answer. So, graphing the equations. If we need to graph y equals x plus 4, and I'm double checking here if yours is already filled. Okay, it is. Sorry. There we go. All right, so we're kind of already given our lines here, but for the sake of knowing how to do this by ourselves, let's make sure we can graph these. So if it says y equals x plus 4, what is the y-intercept of this line right here? Because we know it has to be, we know it's got a slope and a y-intercept. So where's the y-intercept in this equation here? Go ahead and type that in the chat. Okay, so what is the y-intercept for the green equation? What do you think, guys? What do you think? Is it gonna? I'll give you a choice. You got either 1 or 4, right, for this green one. All right. Anybody else? All right. Then it is going to be 4, and you're right for the next one as well, Emmett. It's going to be 4 and 2, right? So those are going to be our two y-intercepts. So y-intercept is at 4 for this guy. So we're going to place a dot at 4 on the y-axis. Okay. And I'm going to hold off on that other one for now. So that's a y-intercept. Where's my slope? Again, if it's y equals mx plus b, the slope's going to be right in front of the x, right? So you want to type real quick what those two are there for me, Emmett? Okay, positive and negative, true. We'll have a positive and a negative slope. And if there's no number there, it's going to be a 1, right? So this is going to be a positive 1 slope. And this one is going to be a negative 1 slope. Right? So good. So now's the easy part, okay? If we can recognize that, then we're good. So we say, okay, start at 4, and then our slope is positive 1 for this first one, right? So we can say our slope is positive 1 or 1 over 1. And that's going to be our rise over run. Rise over run. Okay, so rise 1, run 1. Rise 1, run 1. Place the point. Rise 1, run 1. Okay, and we can go backwards. Down 1, left 1. Down 1, left 1. All right, so that's one of our lines, right? And then the other line, let's do as well real quick. Nice, excellent, Bear. So we, all right, so our y-intercept's at 2, right? And our slope, you said, Emmett, was -1, right? So we can say -1, nice. -1 over 1. So we'll say down a rise of -1, right? Down 1, right 1, down 1, right 1, down 1, right 1. Okay, until I can get a line and I draw my line. Okay, so what I want you to do, Emmett, is now just see where these two intersect. Okay, so I want you to go to your Google Draw file and see if you can fill in the answer there of where those two lines intersect. All right. Did you get it? Almost. All right, -1, 3. That is correct. 1 to the left and up 1, 2, 3. So that is our solution. Ba-ba-da. Nicely done. So right there, -1, 3 is going to be our solution. Okay, -1, 3. And on your Google Draw, I think you can drag this little dot here, and place it right there. Okay, if you want to. All right. Good. So for now, you still there? Uh-oh. Okay. So for now, notice I've been giving you guys these two lines. I'm not going to have you guys graph these two just yet. Or I'm not going to have you guys graph the lines on most of these. We'll give them to you, and I just want you to see where the intercept is. Emmett, can you hear me? Give me a thumbs up if you can hear me. Or is it too glitchy? Okay. Okay. If you ever can't hear what I'm saying, then let me know. All right. Okay. So basically what I said was for the time being, we won't have you guys graph your two lines. I was showing you how to do that because we will be moving towards that next week. But for now, I just want you to notice where the solution is. Does that make sense? Okay. Does that make sense though? So we did a little extra work because that's what we're moving towards. But for now, I'm not going to have you graph these, but just find the solution. Okay. So we're going to do this one together. We're going to check, is this point a solution to the system? Okay. So we got our answer, right, on that last one. Now, how do we know this is right? We're going to check our answer. Okay. So make sure you're following along with me here, Emmett. Let's see. -1 is x, right? And 3 is y, because each coordinate point ever in the world is going to be x comma y. Right? So now I just say, okay, I'm going to plug this in for all my x's. -1, -1. I'm going to plug this in for my y's, 3, 3, and see what we get. All right, what do we get for this top one, Emmett? -1 plus 4, what is that going to give me? 3, right? So is 3 equal to 3? Yep. Thing that works. -1 plus, oh, wait a minute. Negative of a -1. What does that make? Okay. Well, negative of a -1 would be +1, right? And then plus 2 makes it 3. Good. So we have 3 equals 3 again. Oh, okay. That's also a true statement, right? So we're good. So yes, it is a solution to the system. All right, moving right along because I want us to do an activity here in a sec. All right. So practice. This is the next one I want you to do. This is the other one on your Google Draw file, Emmett. And I want you to do this one on your own. Okay? So you're going to look at your two equations. I've already graphed it for you, so you don't have to worry about graphing it. So all you have to do is just see where these two lines intersect. Okay? And then write your answer here and drag your dot and put it at the point. Once you think you got it, go ahead and type in the chat. Okay. She said 2, 2. That is correct. 2, 2 is where the two lines intersect. And I could take my little green point and place it right there. Excellent work. So, and again, as long as you go through the steps of graphing the solutions or the equations, right? Starting at your y-intercept, getting your slope, doing rise over run for each, then just looking at it and getting your solution is not too bad, right? It should be pretty on the easier side, which is good. Okay, now, so far we've seen systems of equations where two lines are hitting each other, right? Now, what happens if they are parallel lines? What happens then? So what do you think? I'm going to ask you to answer me first, get your brain thinking a bit. What is my solution going to be if I have two lines that are parallel, that never touch each other? What is my solution going to be then? Aha. Okay. There won't be a solution. That is correct, Emmett. Good job. So there won't, if we say, what is the solution to the system of equations? There won't be a solution. Okay. So we look at these two lines, and first of all, what do you notice about these equations here? And if you want to unmute your mic, feel free to, Emmett. What do you notice about these two equations? I don't know if I can hear you. It shows that your mic is off, but I don't hear any sound. Dang. Maybe we'll have to play with it later. I can't hear you still. Sorry. Huh. If your headphones are still plugged in, that might be affecting it. Okay, it has the same slope, but the y-intercept is different. Okay, that is true. That's what I was trying to get you to notice. Good job. So they have the same slope, right? Slope's the same, only the y-intercept is different. So that's why they start at different spots, but they're both parallel. They're both the same slope. And that's why, whether you're looking at this, okay, or you're looking at this graph, you'll notice that, hey, these are parallel lines, so they're not going to touch each other. Or you could know that even just from looking at this, even if you didn't have this. Or when you graph it and you see that they're parallel, you can say, hey, these are never going to touch. So there's going to be no solution, right? No solution. All right, so that's what's going to happen if there's parallel lines. No solution, okay? Now, what about if we have two lines that are the same Okay, so this one, and sometimes it can be disguised. So for example, what if we had y equals I can hear myself. Let's see, 4 over 6 x minus 1. I know that 4 is hard to see. That says y equals 4 over 6x minus 1. Sometimes it might say something like that. Okay. And you're like, oh, here's two different lines, right? Here, y equals 2/3 x minus 1, y equals 4 over 6x minus 1. But really, those are the same line, right? Okay, so be careful. Because sometimes it'll look like two different lines, but it might be the same line. So, but if you simplify 4 over 6, that's 2/3, right? So that's actually the same line. So what do you think now? I'm going to ask you again one last time. What do you think the solution is going to be this time if it's the same line? If the lines are right on top of each other, is there going to be a solution? Is there not going to be a solution? Is there going to be multiple solutions? What do you think? It will be the same solution. What do you mean by same solution? Do you mean there'll be one solution, no solutions, or multiple solutions? So basically, is there going to be one solution, 0 solutions, or like a number of solutions? One solution, okay. So let's check it out. If we have our two lines, they've already been graphed, and it's just one line really, right? So we graphed one line, we graphed one line right on top of it, and now we see that they're going to have, sorry, let me scroll back up real quick. For these, we said, where do they intersect, right? Where do the two lines touch? And we said, okay, there's one spot where they hit each other, right? Here, we said, okay, where do they touch? Well, they don't touch at all, so there's going to be no solution, right? Now here, we say, where do they touch? Well, all over, right? This line is touching this line infinitely many times. So do you see this here? So purple and blue both intersect right here, right? And here, and here, and here, and here, right? Infinitely many times. Okay, even smaller than the dots I can make. They touch infinitely many times, okay, and it goes on forever. So they go on forever. Now that means that our solution, sorry, I'm trying to think how to phrase it. Infinitely many solutions. Infinitely, I think that's spelled correctly. Infinitely many solutions. Okay, so we've got one solution. We can have it where we have no solutions, and we can have it where we have infinitely many solutions. Okay, so now to end it off, just for you to kind of see how you want, and if you want, I can play too, and you can tell me in the chat. But I was originally going to have a Kahoot that we were going to do online, so you can see how you're doing. You want to give it a go? We'll finish up with that. All right. Any questions so far? Anything that's giving you confusion? Doing okay? All right. Then, this is it. There we go. And if I can figure out how to do it myself, then I'll play too. And then you can see if you can beat me. All right. Okay. Screen share should be still on. Yeah. And I'm going to try to join here. Okay. Nice. I like the face. All right. Kahoot. It. Six, 8, 8, 0, 8, 3, oops. 0, 8, 3, 9. Okay. All right. Let's do it. So, question 1. What is the solution to the system equations graphed below? So where do they hit each other? All right. So they're going to hit each other at 1, 2, 3, comma 1. So 3 over 1 up. So 3, comma 1. So that's tricky there. So just make sure it's in the right order. All right. I stole some points. All right. What is the solution to the system of equations graphed below? X comma y. All right. Nicely done. Yep. 2 over, up 1. Very good. Making a comeback. What is the solution to the system of equations graphed below? All right, nicely done. 4, comma 2. It's actually kind of hard for me to type it in on my phone while watching this. What is the solution to the system of linear equations graphed below? Oh, dang. Put the wrong one. Good, so no solution, right? They're never going to touch. So it should be no solution. Excellent job. Oh, man. Changing, making moves. What is the solution to the system of equations graphed below? Always fast. Nicely done. Infinitely many. Because, and again, here's what I was talking about. They look like different equations, don't they? But if we rearrange this red one and solved for y, it would look the same. So, all right. Uh-oh. Things are getting dicey. How many solutions does this system of equations have? So how many solutions? right, excellent work. So the giveaway on this one is the slope, right? We see that there's the same slope, so they're either going to be the same line or parallel. And then we look at this and we say 5/6 is not the same as 10, right? So these are parallel lines. They're never going to touch. So it's no solution. Good job. All right. How many solutions does the system of equations below have? All right, so this one, -6/7, 7/6. So this is kind of complex looking. It's not too bad, but there's no same slope, right? So they can't be no solution or infinitely many solutions. So it's got to be one solution on that one. All righty, ooh, just barely edged through so far. How many solutions does the system of equations shown below have? Nicely done, infinitely many. It's the same equation. All right, a system of equations with one equation will have lines that with one solution. All right, good job. They'll touch once, right? With one solution. Good. All right, two more questions. Systems of equations with no solution will have lines that are parallel and never touch. Good. So a system of equations with no solution means that they'll never touch. Good. All right. Super close. And last one. System of equations with infinitely many solutions will have lines that... Oh no, I put the wrong one. Ah. So it's going to be ones that overlap, right? That are right on top of each other. So what I should have put... Oh man, and that was enough. It was enough for you to get it. Nicely done. Very, very good. So that's the kind of the main three things there, okay, is, and everyone else that watches this later, is that infinitely many solutions, it's the same line, they're right on top of each other. One solution intersects at one point, and no solution is parallel lines, they never touch. All right, very, very well done. So your assignment for today, okay, is going to be this IXL practice, okay? We did this one on Tuesday, so if you already did this one, you obviously don't have to do it again. Just make sure you're caught up on this one. And then this other IXL practice I'll share with you. Don't click on the one that's on here, okay, Emmett, and those that are following along later. I'm going to give you guys a different one than this, okay? So basically, I guess what I should say is check on Google Classroom on the first post. Okay, I'll edit it and I'll tell you which sets to work on. Okay, I guess I can go ahead and tell you this one. This one was the AA1. So if you already have AA1 to 80, then you're good. Otherwise, make sure to get this one done, and then look for the other one on Classroom. Alrighty.